Welcome back to my AI-powered mapping series for web developers. Today we're going to be building a walking path difficulty classifier using TensorFlow.js. We'll analyze elevation data to classify paths as easy, moderate, or hard, and display insights about the terrain directly in our mapping application. So let's jump right in. Okay, we've got our starter files ready to go. In the HTML, I'm going to add a CDN link to TensorFlow. Then I'll also add divs for our walking path info, the difficulty, the insights, and the elevation details. I'll next adjust the CSS to have the map take up only half the page to leave room for the path info. Now let's go on to the JavaScript. In here, we're going to require several things, including Esri graphic, Esri rest route, Esri rest support route parameters, Esri rest support feature set, Esri geometry point, Esri geometry spatial reference, Esri layers graphics layer, and Esri rest network service. All right, now inside of our map logic, I'm going to create a coordinates variable and a graphics layer, which will be added to my map. Next, I'm going to create an event listener, which will listen for clicks on our map. We'll then check if coordinates.length is less than 2 to make sure we've collected only 2 points. When the user clicks, we will get the map point and store its longitude and latitude in the coordinates array. We'll then create a blue marker on the map at the clicked location using the map point's coordinates and display it in the graphics layer. Now after the second click, our coordinates.length is equal to 2, which will trigger the route calculation, signaling that we now have points for our route. We then create point objects for the start and end locations using the stored coordinates. All right, next I'm going to create a fetch walking travel mode function to request the description of the routing service from ArcGIS. Now this includes details like supported travel modes. We're going to pass the service URL and our API key. Once we receive the service description, we access supported travel modes, which contains different modes like walking, driving, etc. Next, we create an add route function. And in here, we're going to create a walking mode variable, which holds the fetch walking travel mode result. Then I will create a route params variable to define our route. And this will include our stops, our return directions, and our travel mode. We're then going to call route.solve with the route URL and parameters. And this solves the route between the 2 points. Now, once the route is solved, we use for each to iterate over the route results. We'll set the route symbol to a blue line, add the route to the graphics layer to display it on the map, and call calculate path difficulty to calculate the difficulty of the route based on the path's geometry. Now, next we're going to call display directions to display the generated directions on the screen. And if something goes wrong, the catch block will log the error. Next, I'm going to create the calculate path difficulty function. We're going to use await get elevations from many points to fetch the elevation data along the route. We'll calculate the elevation gain and max slope from the data using extract features. Now, using model.predict, we're going to predict the difficulty based on the elevation features. And we get the predicted probabilities and the predicted class, easy, moderate, or hard. We call display path difficulty to show the predicted difficulty and probabilities. We'll also display the elevation details with display elevation details. Next, in the get elevations from many points function, we're going to send a post request to ArcGIS Elevation service with the points and token. Now do note that this elevation service is currently in beta as of December 12th, 2024. Next, we're going to extract the elevation z value from the return data. And then we're going to return an array of elevation values. Now I'm defining the extract features function to calculate 2 key features from elevation data. And these are the elevation gain and the max slope. All right, next I'm going to define a neural network model using TensorFlow.js. I'm using TF sequential, just like I did yesterday, which is a linear stack of layers. Now, similarly to yesterday, we're going to have a dense layer, and this will have 10 units. This layer will take an input shape of 2, meaning each input has 2 values. And then the second layer is going to be similar, but this will have 3 units, and this will actually use softmax activation to output probabilities for 3 possible classes: easy, moderate, or hard. All right, next I'm going to compile the model with the Atom Optimizer and categorical cross-entropy loss, which is suitable for multi-class classification. The model will also track accuracy as a metric during training. All right, now I'm going to train the model with the sample data. We've got our X train, which is the training data, Y train, which is the labels, and then I'll train the model with model.fit, passing the input and labeled tensors and specifying the number as 100 for the training. Now finally, I'm going to call train model to begin training the model. All right, next I'm going to define the function display path difficulty. I'll create an array called difficulty labels with 3 values: easy, moderate, and hard. Next, I'll use document.getElementById to target 2 HTML elements, path difficulty and path insights. Now let's move on to display elevation details. And in this function, we're going to show the elevation details like total gain and slope. So first I'm going to calculate the elevation gain, which is just the difference between the highest and lowest elevations. And for slope, I'll divide the total elevation gain by the number of data points minus 1 to get the slope in meters per kilometer. Now I'm going to create a function to display the route directions on the map. And in this, we're first going to create an ordered list to hold all the directions. I'll style it with a class and set its margins and padding to make it look nice. Then I'm going to loop over all of the features inside route results 0.directions. And each feature contains a piece of the directions. And I'm going to create a list item for each direction. Next, I'll display the text of each direction and show the distance in miles formatted to 2 decimal places using toFixed 2. And after creating the list item, I'll append them to the ordered list. And finally, I'll clear any existing UI elements in the top right corner of the map and add the new directions list to the same area. All right, let's go ahead and see this in action. When I click 2 points on the map, it's automatically going to calculate the walking route between them. And the blue line will represent this walking route. Next, it will calculate the path difficulty considering the elevation gain and slope. Now using TensorFlow, it's going to classify it as easy, medium, or hard. And so here, for example, the path is moderate, and we display the prediction probabilities for each different classification. So we're also going to get elevation details like total gain and the maximum slope of the route. And that's it. That wraps up today's demo. We've built a walking path difficulty classifier using TensorFlow.js to analyze elevation data and give insights about the terrain in our app. Be sure to come back tomorrow for another AI-powered mapping app. And as always, happy coding!